Okay, number systems, this is a quick overview. So we've got a few terms, and a numeral is what we're going to start with. Numeral is a representation. Alright, so numerals are symbols. Symbols that represent numbers. And there's all sorts. This is not a history lesson, so I'll just quickly rattle a couple off. So as well as Egyptian, which was a base 10, there was Babylonian, which is base 60, which is a bit crazy. However, they did achieve a lot. Greeks had a base 10 system. The Romans made their numbers out of the symbols you see there in bronze, and it was interesting. It served its purpose, but if you had to write 1894, you can see what we get there. So yes, examples of numerals throughout history. So these days, what we, quote unquote, use is the Hindu-Arabic system, which has digits, as you know, from 0 up to 9. We have 10 digits. Our numbers comprise of combinations of those. So they're numerals. In our Hindu-Arabic system, we've got systems inside there. We have types of numbers. We're first going to look at natural numbers. Natural numbers has a symbol capital boldface N. So all of the number system symbols have what's called boldface. So it's like capital with usually the middle member is wide. So the boldface N represents natural numbers. Now natural numbers, we have a list like this. Dot dot dot, meaning it goes on and on and on. It doesn't actually cease, but it does start. Now there is always some debate about whether it starts at 0 or 1. It does depend on the situation or who your preferred person is that you're listening to, but you definitely see both the natural number system starting at 0, and other times you see it starting at 1, which can correspond with things like counting numbers or whole numbers. They can mean the same thing. So if it's counting numbers, it would make sense that it starts at 1. Whole numbers, or the size of a set, which is called the cardinality, often starts at 0 because you can have 0 elements in a set. So it depends on the context of it. So natural numbers, boldface N, whole numbers, starts at 0, can go as far as it needs to. There's no actual end. It can go on towards infinity. Starts at either 0 or 1. Sometimes if you have boldface N with a subscript 1, it can mean the system that starts at 1. Likewise, boldface N with a tiny little subscript 0, it means it starts at 0. Next we have integers, which we talk about quite a lot. Integers can have the symbol boldface Z, or sometimes boldface J. Both are used. I see the Z more often, so boldface Z, sometimes boldface J. We've got it's a list just like, in some ways, natural numbers and so on, but it includes the negatives as well, and definitely includes 0. And so we go from negative infinity through to negative numbers like -2, -1, 0, 1, 2, 3, and so on. Okay, so they're integers. Again, whole numbers, no fractions, but it can be negatives as well. Negatives, positives, or 0. The symbol Q pertains to rational numbers. Rational numbers are numbers that can be expressed as a fraction, even though they may not look like they're expressed as a fraction. They can be like 3. 3 can be 3 on 1. 3 can be 30 on 10. It can be many, many things, but 3, or its equivalent, can be expressed as a fraction where we have A over B, and A and B are themselves integers. So the number on the top and the number on the bottom are expressible as integers. They need to be, B can't be equal to 0, because you can't divide by 0, but rational number can be expressed as a fraction. And so provided you have an integer over an integer, that is basically okay to be called rational. Boldface Q. And as a note there, if it's not rational, it must be irrational. Sometimes irrational has a Q with a bar on the top, or sometimes Q with a prime there, Q prime with that little stroke, or the bar on the top means irrational. So a number is either rational or irrational, and that applies to all numbers. It's rational or irrational. Well, all real numbers, which I'll get onto that in a minute. All real numbers are either rational or irrational. Okay, so that means it can't be expressed as A over B. Alright, so that is not expressible as A over B. And irrational numbers are non-terminating and there's no discernible pattern. So something can be non-terminating, like 0.3 recurring, which is a third, but that's rational because you've got integer over integer. This one's got no pattern. More about that in a future video anyway, so rational or irrational. Okay, so next is real numbers. Yes, we have real numbers next. So real numbers are anything that can be put on a number line. Which you're thinking is probably everything you've ever come across so far. Anything suitable for a number line. So it includes all of the ones we've mentioned. So all the sets from whole numbers, natural numbers, counting, we've got integers, rational and irrational, all of those. They're all types of real numbers. So anything that you can put on a number line. Okay, so 2/3, pi, square root of 2, -1, -1/7, 0.5, okay, 6, okay, these are all real numbers. You can put them on a number line. So what's beyond that? Well, not that many people deal with numbers beyond that. So however, some do, and some find it very important. And so it brings us to the last one here, complex numbers. So complex numbers are important in certain fields for solving certain types of equations and applications like electrical engineering and so forth, three-phase power. So a complex number is a number. It's almost like a two-dimensional number because you can draw it on something that resembles a Cartesian axis system, even though it's not. It's called an Argand diagram. But it's a number that has two parts, and it's in the form of a plus bi, like 5 plus 6i, for example. All right, or 7 minus 2i. And basically it's got A and B themselves are real numbers. So you could have pi minus 1/3 I, okay, but it has this operator called I, and I is the square root of -1, and you're going, you can't take the square root of -1, my calculator says you can't. Well, more about that in a future video. So it's made up of two parts, a real part and an imaginary part, which we'll flesh out a bit more in a video coming up, and I do believe that's enough for now.